myself. Hello, my name is Jessica Leo and I am in grade 10N. In this video today, I will be talking about my high school math 2 big project for quarter 2. And this document will focus on real-life parabolas, water arcs. So as you can see in the first page, I have the table of contents. Then if we scroll down, I'm going to tell you more about what this document will focus on. So for the big project this quarter, we focused on how we can apply math in real life. And to do that, we worked on finding quadratic equations for real-life parabolas, such as water arcs from water fountains, and also creating our own designs. This document will show the work I've done to achieve the end product, and I show you how I get my equations and the steps I took in order to complete all the different phases of the big project. So if we move down here, we just have information such as like keywords and stuff like that. Now we have the introduction. So I'll be talking more about what this project will focus on. So like I said before, we're continuing on to focus on how we can apply math to real life. This quarter we talked about finding the equation that would match different water arcs, which coincidentally is also in the shape of a parabola. So that was what we needed to do for the first phase of the project, and for the second phase, we needed to take a picture of a water arc that we create by ourselves by using different water appliances such as a water hose, a drinking fountain, or an actual fountain, etc. Then we would need to create another equation that matches that particular arc that we have created. And lastly, to finish everything off, we would need to design and create our own water arc and find the equation for that too. So I have 4 different objectives for this big project that I would like to achieve. The first one is to be able to create a quadratic function with the information given. The second is to be able to take a picture of a water arc and create a quadratic equation. The third one is to be able to design my own fountain and create a quadratic function. And the fourth one, which is my last objective, is to be able to learn more about the math standards and to understand and apply them to real life as well as other subjects. I feel like all 4 of these objectives are really important because they all matter and it is all something that we can use in real life and can relate to. So I had a small limitation, a small problem that I had. This occurred in the second phase of my project. So what happened was I took a picture of the water arc, I measured it, and then I found out the equation for the arc. But once I tried to put the picture and the equation into Desmos, they wouldn't fit together. So I was freaking out because at first I thought it was because I did the equation wrong, but that wasn't the problem either because after looking at the equation for many times, like multiple times, I realized that I was right. So instead of having to retake the picture again, what I did was I used the application Paint and I set up a coordinate system and then measured the arc using pixel coordinates. And after that, I was able to successfully fit the parabola with my picture. And I'm glad that I was able to figure that out because by using the coordinate system, it made it really easy for me to measure my water arc than measuring it in real life. So now we're going to move on to methods. So phase 1 was sort of the methods and practice area for which would help us or like prepare us for phase 2. Because phase 1 focused on how to find the equation from the information, and that's important for us to be able to take it to the next level or like to start phase 2. So the question for phase 1, there were 2 water arcs that we had to find the quadratic equation of, water arc A and water arc B. And so first, what I did for water arc A was we need to find the quadratic equation by using the formula f bracket x bracket equals to a bracket x minus m bracket x minus n brackets. That's a lot of brackets. So this formula will help us figure out the equation we need for the water arc A. So the information given to us is that parabola jet height is 2.5 meters and the parabola horizontal jet spray, the distance is 4.5 meters. So with that information, we know that the distance, n, will equal to 4.5, and the starting point will be 0 for the x-intercept. And now we want to find the distance between 4.5 and 0. So to do that, what we need to do is divide 4.5 by 2, and this will give us 2.25. We're going to use this information later on in the process. So going back to the original formula, what we want to do now is replace the variables. So if you don't know what a variable is, which I'm pretty sure you do, a variable is a quantity that can change in a math equation, and a letter usually represents it. So that means the variables in our formula will be m and n. We need to replace those variables with the numbers we found before, which are 4.5 and 0. So the formula will now look like this. So now what we want to do is take the distance between 4.5 and 0 that we found before, and we want to replace the fx, which is in the beginning of the formula, and all of the other x's in the formula with that number. So as you can see, I have changed that in the formula. And now what we want to do is take negative 2.25 and 2.25, and we want to multiply them together. So this will give us negative 5.0625a. After that, what we want to do is take the 2.5 and then divide it by that number. So that will give us negative 0.4938. So that means that we will replace the a in our function, in our formula, with that number. Now if I scroll down here, you can see we replaced the a with that number, and the final equation will be y equals to negative 0.4938x squared plus 2.222x, and that will be our quadratic equation for the water arc A. Now for water arc B, we want to do the same thing, the same process, except we just want to replace the numbers. So like I said before, we're starting out with the same formula, and we're just going to change the numbers. So x is still going to be 0 since it is our starting point, and the n is different because the distance is going to be 1. So now we want to take 1 and divide that by 2 to get the distance between 1 and 0, and that gives us 0.5. Now we need to replace the variables in the formula. Once again, it is m and n, and the formula will now look like this. Now we want to replace all of the x's with the 0.5, which is the height that we found. And so the formula is going to look like this. And we just want to multiply 0.5 times negative 0.5, and that gives us negative 0.25a. So this will be replacing our variable a in our function. Now we're just going to take a equals to 0.5 divided by negative 0.25, and that gives us negative 2. So as you can see, if I scroll down, our final quadratic formula for water arc B will be y equals to negative 2x squared plus 2x. If I scroll down here, you can see that I have inserted a picture of the graph. So the purple parabolic arc will be the water arc A, and then the green is going to be the water arc B. All I did was I used the website Desmos to insert the equations that we found, the final answers that we have found, and then put them in there. Then I just defined the domain and range, and I was able to get this graph. So by knowing how to create a quadratic equation by using the information, I'll be able to use this knowledge to be able to find and finish phase 2 of this big project. This will be the method that I will use to complete the rest of phase 2, since I will be following the same steps as I have shown you above, except I would just place the numbers. Now for results, this is phase 2 of our big project. So for phase 2 of the big project, we need to find our own equation for a water arc that we create. I took a picture of a water arc by using my water hose, and I wanted to do this because it's kind of like a mock-up of a water fountain that I want to create later on. So it's like giving me the imagery of how it will look beforehand with like a fake water arc that I can later use to put in my actual water fountain. So the first thing I did was I took a picture of the water arc, as you can see here. And then I measured the distance using paint, and I set up the pixel coordinates. So my height was 36 centimeters and my distance was 16 centimeters. So this way it would be easier for me to get the parabola to match my water arc. Then I created my equation using the information given. So once again, I'm using the same formula as I had shown above, but I'm going to replace it with the different measurements. So like I said before, the n will represent our height and the x will represent our starting point. So our x is still going to be 0, but our distance will change because it's going to be 16. So moving down. Now we want to find the distance between 16 and 0. So to do that, we just need to divide 16 by 2, and that will give us 8. And moving down. Now what we want to do is take that number, and we're going to replace our fx and all of our x's with 8. So as you can see there. Then we're going to take 8 and multiply that with -8, and that will give us -64. Now we're just going to take 36 divided by -64, and this will be our replacement for a. And as you can see, we just have to take -9 over 16, and that gives us -0.56, so that will be our replacement for a. And the last part is the figuring out the equation. So that means that the final equation for my water fountain will be fx equals to -0.56 x squared plus 16x plus 0. So this will be the final equation for my water arc. And the last thing that I did was I graphed in Desmos, and I put the picture in the website, and then I put the equation, which is -0.56 x squared plus 16x plus 0, and then I put that underneath the picture, and then I just defined the domain and range of the parabola, and I was able to get a perfect parabola arc. And this actually took me a while because my arc, it was originally very high, and so it took me a while to define the domain and range and get it to fit the graph. But in the end, it worked out, and I think it turned out pretty nicely, I hope. Okay, so enough talking. Now I have another picture graph to show you. So this graph shows you different heights and distances the parabola can go. So I did this because I wanted to see if we could change the measurements by using the same equation, and I was right. So to do the different arcs, what I did was I used the formula ax squared plus bx plus c. So this is going to be the formula that we use to change the distance and height of our arc if we want to see different measurements. So all I needed to do was replace the a with any number to make the water arc go either higher or lower. And this will be helpful for me later on because I can make different designs for my water fountain, because I can have different distances and heights for the water fountain to make it look more intricate and have different patterns and so on. So as you can see, I just put in the 3 different equations. I changed the number here, which is the a part, and then I have 3 different parabolic arcs. This one, the blue one, is the original one, and then this one is going lower and this one is going higher. Okay, now moving on to phase 2, part 2. So in the second part of phase 2, we need to create and design our own fountain using parabolas. So I decided to create a water fountain that can be placed in malls or other green areas such as parks, gardens, etc. And I wanted to do this because I think that water fountains are very beautiful, and I would love to create a water fountain one day, and hopefully this design that I am about to show you will end up in a park or a mall somewhere one day. So to create my fountain, I used the application Paint, and the water fountain that I created has 2 different water arcs, so it has 2 different patterns or designs. So if I just scroll down a moment, this is my beautiful water fountain. I actually used the application Paint to do this, so it kind of it didn't take a while, but it was kind of hard to get it to look somewhat presentable. So my first water arc is shown through the dark blue color, as you can see. So it's this one right here. Oh no, I just moved it. Okay. So the measurements is 7 meters high with a distance of 10 meters. And for my second water arc, which is shown through the light blue color right here, the measurement is 5 meters high with a distance of 3 meters. So with this information, I can create another quadratic equation that will fit this particular parabola. My inspiration for this water fountain, though, was that the base had like a water, and then like the middle would be kind of like a cup, and there are two levels to it. So the first water arc will go into the first puddle of water, and then the second one would go higher into the cup puddle of water, and then that like small blue triangle thing is kind of like a hose where it can shoot out the water. So yeah, and then the circle in the middle is just supposed to be like a decoration, like a marble circle or something. So that was my inspiration, and I really want this design to be placed in a like mall or something. So I got this picture of a mall in California, I believe. Moving on. So for the first arc, I used the same function, the same formula that I used previously, which I will repeat again, is f bracket x bracket e equals, f bracket x bracket equals to a bracket x minus m bracket x minus n bracket. That's a handful to say. So, all we need to do is just follow the same steps that we did previously in phase 1. So like I said, phase 1 was more of a practice round to get us to understand what we need to do. And all I needed to do was to switch the numbers so that it will fit with the information that is shown above. So the height is going to be 7 meters and the distance is going to be 10 meters. So here we have 7 on the outside, which is the height. Then we're going to take 10 divided by 2, 10 divided by 2, which gives us 5. So 5 minus 0, 5 minus 10 over here. Then we're going to take that, 5 minus 0 is 5, 5 minus 10 is negative 5, and we're going to multiply these numbers together, which gives us negative 25. Then we want to take the height and divide it by the number that we got, so 7 divided by negative 25, which equals to negative 0.28. And then we just have to add the x squared to the formula. So our final equation will be f bracket x bracket equals to negative 0.28 x squared plus 10x plus 0. And here is a picture of the graphing of the water arc. So as you can see, I have the function here and the image of my water fountain. And here it is the point in which it reaches the top height of the water arc, the first water arc. So as you can see, this is the point in which it is at its highest point, and it is 17.86. So yes. Now we have the second arc. So this is the smaller arc that goes on top of the water fountain. So we're going to follow the same procedures except change the height and distance. So the height, which is 5, is going to stay on the outside, and we're going to take 3 meters, which is our distance, and divide that by 2. That gives us 1.5, and then after that, 1.5 minus 0 equals to 1.5, and 1.5 minus 3 equals to negative 1.5. Now we're just going to times that, multiply it, and that gives us negative 9 over 4. And now we need to take 5 divided by this number right here, and that gives us negative 20 over 9, which in decimal form is negative 2.22. After that, we need to add our x squares and etc. And our final equation will be f bracket x bracket equals to negative 2.22 x squared plus 3x plus 0. So as you can see, this is the picture for the second water arc, the smaller water arc. And I put the original equation on Desmos, and then as you can see here, this is the point in which the water arc is at its highest point, and that's going to be 0.676. Okay, so now we're going to move on to discussion and conclusion. So the first thing I'll be talking about is my analysis. So throughout my project, I analyzed that all the equations use the same formula, which is this formula shown below. And all we have to do is change the numbers to fit the equation. I also analyzed that each phase was preparing us for the next stage. So if we understood how to do the previous stage, we can complete the next stage. And for example, the first stage helped us to understand what we would need to do in order to create an equation. The second stage helped us to understand how to create a function from a picture that we take ourselves. So this is when we start using a little bit of what we have learned and using it in real life. But the last phase, the third stage, helped us to understand how to design our own function and our own equation and use everything that we have learned and make it reality. So the third phase combined everything together. And in the second phase, I also analyzed that if we use the formula ax squared plus bx plus c, we can actually change the height and distance of the original formula. We can use the formula to make the water arc either higher or lower, and this is helpful for part 2 of phase 2. Since we're creating our own function, it's nice to know or have the knowledge of what will happen if we decide to change the measurements of the water arc. I also analyzed that there are different factors that can contribute to the changes that happen to our parabola/water arc. So these factors include things such as changing the a part of the formula to make the height of the parabola lower or higher. The b can move the angle of the water, and the c can also affect the height of the starting point. Also, the level of water shooting out, or the item that shoots out the water, or the level of the floor, can also change what happens to our parabola water arc, since for example, if we use a water hose that has more water pressure, then of course more water is going to come out, so that's going to change the height and distance of our water arc. Or if we hold it higher or hold it lower, that is also going to change the shape and size of our parabola. So like I showed you before on the graph, using the same formula, it changes how the parabola can either go lower or go higher. So in conclusion, I was able to learn a lot about how to create quadratic equations for parabolas, and now I know I can utilize this knowledge to my advantage and actually use it in real life. Because at first I didn't really know how useful this information can be, because I didn't think that we would use it much in real life. But once I stepped back and looked at the quotation big picture, I realized that math is everywhere. And I think I just don't want to admit math is everywhere, but it is, and I have to deal with it. But everywhere we look, we see some math equation. We use math equations without even knowing it, and parabolas surround us everywhere. Water fountains have parabolas. The logo of McDonald's has parabolas. It's everywhere. And I was able to achieve this knowledge by first understanding how to create an equation to fit a parabola, and I learned that in the first phase of this big project. So I used the first phase as a practice stage so I could understand how it works and the steps, and then use that knowledge and apply it to the second phase of the big project. After learning how to create the equation, I put it in Desmos and fit it to the parabola and explain what I have learned. I was able to repeat the same steps for my second phase. When I first saw this project, I thought it would be hard to do, because I saw different equations and I was like, no, this is going to take a long time, it's going to be very hard. But once I understood the concept and understand the step-by-step process, it was so much easier, and I understood what I was doing, and I feel like I have more knowledge, and I was able to learn a lot more about how to create equations and how to use math in real life, which is one of the objectives that I had before. And also, the previous phases helped me to create a simulation of a water fountain design that I really hope to see one day, and it made me realize how useful everything that I've learned in math class and in this big project will be for my future because I can use it in real life. So now I'll be talking a little bit about the standards that we used in math. So the first one is like ASSE2. So in this product, we learn how to do product expansion. So an example of this is A bracket B plus C bracket equals 2. So instead of using the variables in the equation, we need to replace them with numbers. So the numbers that I am going to use are 3 and 6. So the equation is going to change since we need to replace the variables. So the A will become 3, and the B will become X, and the C will become 6. So as you can see, this is the original equation, and now I have changed it so that the numbers will fit the variables. Now we're going to take 3x and add that with 3.6, and that gives us 3x plus 18. And I got 18 because 3 multiplied by 6 equals to 18. Another equation, I'm just going to go randomly. Let's see. Let's do APR1. So this standard focuses on performing arithmetic operations on polynomials. So an equation for this is P plus Q. So P and Q is already given to us before. So P equals to x squared plus 3x minus 4, and Q equals to x plus 5. So what we need to do is just add these equations together. So the formula for P and add it to the formula of Q. So we just need to combine the ones that are the same. So 3x will combine with x to become 4x. And then we just take negative 4 plus 5, which will equal to positive 1. So our final equation will be x squared plus 4x plus 1. This one was one of my favorite standards of all time. I loved that standard. So another standard is FLE3. So this standard, we have to use Desmos, which is a graphing website. And an example is for which x value, f bracket x bracket equals to 2x, will surpass the function y equals to x squared plus x plus 3. So to do this standard, we just need to graph different equations. So the different equations will be y equals to 2x, x squared plus x plus 3, x squared plus x plus 3 is less than y is less than 2x. So the graph will show us how it is exponentially increasing and decreasing. And as you can see right here, the point where they meet, the point where they intercept is going to be 5.085, 33.94. And this is how we can see the difference between the two and the increase and decrease in the graph. So if we move down, just other examples of standards that we can see. There we go. Okay, so now I'm going to be talking about the application of standards in other courses. So we can use math in different subjects such as art, and I am so happy that we can use math in art because I'm someone who really loves art, and before this I never really knew that we could use like math in art because I never really thought about it. I just thought of it as shapes and not math. And so right now I'm going to teach you how to create a fish using parabola curves, and I love this because it's so cute and it's so simple. So you just need to go onto the graphing website Desmos, and then you have to put in the equations y equals to negative 0.1 x squared plus 5, and then y equals to 0.1 x squared minus 5. The reason why one is positive and one is negative is because the positive one will go up, will give the curve going upwards, and then the negative one will give us the curve going downwards. So this will be the body of our fish. So it's going to look something like this. And then after that, we want to cut the lines going here because we want to cut those out. We are going to need to graph x equals to negative 7.07. And to do that, we need to add the domain at the end of the equation. So the equation is just going to look like this, and as you can see, it is cut off. So now we need to change the values so that the tail shows up. As you can see, the tail is supposed to be here. And to do that, we have to change the maximum x value to 15. And then we also want to cut off the graph at x equals to 11 to make a tail. So I changed the domain for both equations. So now it's going to look something like this, and you're going to have the body of your fish and the fish's tail. And now you have a finished fish that is simple to make and really cute at the same time. So I also searched different pictures. If you can, let me try to move this down for you so you can see more of the picture. Okay, there we go. I also searched different pictures. The first one, you can see that there are parabola curves right here. And this is just a little artwork of like fishes and stuff. And it's really cute. If we move down here, this is another like parabola artwork where it's like hair and then like a face. It's very cute as well. And here's like more intricate designs and stuff. And you can see like parabola curves over here too. And also, this is my favorite part because I love food and I love McDonald's, and we can use math to create logos for business companies such as McDonald's too. So if you did not notice, McDonald's has two upside down parabolas. As you can see, it has parabola A and parabola B. So we can use the equation that we used before, which is the one where you can change the height and the distance of a parabola. So it's going to be ax squared plus bx plus c, and this is so we can figure out the curves of the McDonald's logo. So as you can see, for curve A and curve B, I just have the equations for each, like the standard form equation for each curve. So curve A, which is going to be this one, has the final answer will be y equals to negative 1.6x squared minus 8x. And then curve B will be y equals to negative 1.6x squared plus 8x. And I just followed the same formula as before, so that's how I got that. And then down here, I just have a bunch of references that I used. And as you can see, starting from ASSE2 all the way down to NCN plus 9, these are all Shmoop website references. And then if you scroll to the top, the references up here are just videos of how you can use parabolic curves and different websites that I use to find how to apply these standards to other courses. So I'm actually going to show you one. This is really cute. This one shows you how to use parabolic curves in artwork. And I thought this was an adorable idea. Let's just wait for the link to load. Let's see. Okay, there we go. It's blank right now, but in a moment I'm just going to show you how it'll work. Okay. So here we go. This might take a while to load. Okay, here. So super cool math art with parabolic curves. And I love this because it's adorable and it's really simple. Like if you love drawing like me, you're going to have a great time doing this activity. Okay, let's exit out of that. As you can see, all you need is just pencils and an eraser and like a notepad.